In this video, we will be discussing entity relationship to relational mapping. We will see how to convert diagrams into relational schemas, effectively transforming a conceptual database design into a logical structure. Join us to learn how to translate your models into efficient and well-structured relational databases. Let's begin with an overview of the mapping process. On one side, we have the entity relationship model, also known as the model. It's a conceptual representation that uses entities, attributes, and relationships to design a database. This model is then transformed, indicated by the arrow, into a relational schema. The relational schema represents the logical structure of the database, using tables, columns, and foreign keys to organize the data. The first step in converting an diagram to a relational schema is entity mapping. The mapping rule states that each strong entity in the diagram becomes a table in the relational schema. The attributes of the entity become the columns of the table, and the primary key of the entity becomes the primary key of the table. For example, consider an entity called student, with attributes like ID, name, age, and email. This entity is mapped to a student table in the relational schema, with columns for ID, name, age, and email. The ID will be the primary key for the student table. Now let's discuss how to map weak entities. A weak entity becomes a table in the relational schema. However, unlike strong entities, a weak entity does not have its own primary key. Instead, it uses a composite primary key, which consists of its partial key combined with the primary key of its owner entity. For example, consider a weak entity called dependent that depends on the employee entity. The dependent entity has attributes like employee ID, name, and relationship. In the relational schema, a dependent table is created, and its primary key is a combination of the employee ID, which is the primary key of the owner entity employee, and the name of the dependent. So, employee ID plus name becomes the primary key for the dependent table. Next, we'll see how to handle one-to-one relationships. In a one-to-one relationship, each entity in one set is related to at most one entity in another set. To map this, we add the foreign key of one entity to the other entity's table. Alternatively, we can merge the two entities into a single table, if it makes sense for our data. For example, consider an entity employee which manages a department, which is a one-to-one relationship. To map this, we can add the department ID as a foreign key to the employee table. Now let's see how to map one-to-many relationships. In a one-to-many relationship, one entity in one set can be related to many entities in another set. To map this, we add the primary key of the one-side entity as a foreign key to the many-side entities table. For example, consider a relationship where a department has many employees. To map this, we add the department ID, which is the primary key of the department table, as a foreign key to the employee table. Now, let's see how to map many-to-many relationships. In a many-to-many relationship, multiple entities in one set can be related to multiple entities in another set. To map this, we create a junction table, also known as an associative table, that includes the primary keys of both entities as foreign keys. The primary key of the junction table is typically a composite key consisting of the foreign keys from both entities. For example, consider a relationship where student enrolls in course. This is a many-to-many relationship. To map this, we create an enrollment table with student ID and course ID as foreign keys, and we can also include other attributes such as grade. Lastly, let's discuss how to map multi-valued attributes. A multi-valued attribute is an attribute that can hold multiple values for a single entity. To map this, we create a separate table that includes the entity's primary key and the multi-valued attribute. The primary key of this new table is a composite key consisting of the entity's primary key and the multi-valued attribute. For example, consider an entity employee that has multiple phone numbers. To map this, we create a separate table called employee phone with columns for employee ID and phone number. Employee ID plus phone number will be the primary key for this table. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.